Question number 10. In the diagram below of circle O, line segment OB and line segment OC are radii, and chords AB, BC, and AC are drawn. So this part, if you're an English language learner or something like that, don't freak out. They're just describing what picture is going on down over there. Don't let them scare you by putting all these extra words. If they're describing what sounds like the picture, all you need to worry about is if they describe radius or maybe the word diameter, but just use the picture. Don't worry about this part. Make sure you do worry about, though, the bottom, what they're asking for. Which statement must always be true? Ugh, another one of these. These types of questions, again, I want to say one more time if you're watching this playlist. These types of questions a lot of times are recognizing things from facts that you should understand from having studied geometry. But when I do them in a video, I'm going to go through each one of these really slowly. It's going to look like the question takes a long time. But if you just study and kind of know your geometry knowledge, this question should hopefully only take about a minute or two as you kind of look through each one and think in your head about it. So I'm going to need a lot of paper. Let me flip this over. Which statement must always be true? Actually, maybe I'm just going to draw. I might just draw on the tab here. Okay. So that angle BAC should be congruent to angle BOC. Ugh, that was off. Well, they do both hit the same. Whatever. They do both hit the same arc, so that's indicative of something. But you should remember that if I have a central angle, which means the corner or the vertex of my angle is touching the center of my circle, if I have a central angle, it's equal to the inscribed arc. So again, a lot of times I put numbers here just to kind of prove to myself. The numbers just come out of my brain. It's from nowhere, really. You don't need to put it, it's not like I say, all right, this angle is 110, that the angle has to be 110. That's not part of it. It's correct or not. So let's say this angle over here is 100. We're just pulling that out of nowhere. Well, that means that my arc that my central angle hits also needs to be 100. But then you should also know the fact that inscribed angles, which means the corner of my angle is hitting the edge of the circle, and also that both legs hit the circle, my inscribed angle should be half of the arc that I intersect. So these do both hit the same arc, but if this is 100 and this is 100, well, that means that my inscribed angle will be half of that. It will be 50. So this statement here, not always true. If we look at answer number 2, though, the measure of angle BAC should always equal half the measure of angle BOC. Well, they both hit this same arc, and the central angle is equal to the arc, so if this is 100, that's 100. The inscribed angle is half of the arc. So it really looks like number 2 is going to be my answer, because if my inscribed angle is half of the arc, and my inscribed and central angle hit the same arc, well, then my inscribed angle will always be half of my central angle. Let's see. But let's just check. That looks like it's good, but let's make sure. 3. Triangle BAC and triangle BOC are isosceles. That looks like in the picture that they drew it could be true, but here's the part where the description is important in terms of stuffy math teachers grading the Regents exam. This picture, this is the description of actually the figure. This picture is just a way to kind of help you out, but in this case they use it as a way to confuse you, because New York State Board of Education just likes to confuse their students. If I draw a picture using just the description they give, well, I've got a circle. I've got center of it is O. I've got OB and OC are 2 radii. And then the chords that I'm going to draw, well, maybe this chord goes this way. They didn't say the chord, they didn't say that angle A and angle O needed to line up, perfectly with the bisecting the two angles makes them hit each other. So maybe my chord goes like this, and then the other chord goes like this, and this is A, B, and C. This picture that I drew, it looks funkier than the picture they gave you, but it still follows the description they gave up here. So technically, this could be the actual image that they're trying to describe. And now in this case, I'll draw this BC. Maybe BOC is an isosceles triangle, but triangle ABC is not necessarily isosceles, because it looks like I actually almost made it isosceles because I made AC almost a diameter, but it's not quite. So here's a case where you look at the picture and you only look at it, you're going to get punished. You can't assume that this is to scale. So that is not true. The area of triangle BAC is twice the area of triangle BOC. That's kind of craziness. They're going to be asking you to then use the arc to find the angle, and use that angle to assume that it's isosceles and find that using SOHCAHTOA. That's too much for this. That I'm going to say that's not my answer, and I'm not even going to really describe that. And yeah, indeed, checking the answers, this is the correct one. Number 2, this statement should always be true. This is your central and inscribed angle rule, where my inscribed angle is half of the arc, where my central angle is equal to the arc.